All the same transformations that we can do on the functions that we've learned so far can also be done on the exponential functions. So let's just think about what this means. Let's start with a vertical stretch. This is a vertical stretch of a factor by a factor of 3, and it is outside the function because the function is always the base with the exponent. So what that does is it changes all the y values to 3 times their value previously. And so if we think about this value here, it was at 1, and if we multiply 1 by 3, then we're going to have it now be at 3. So you don't move it 3 units up, but you multiply its y value by 3. And we talked about before that it has a height of 1 from the x-axis, and so now it's going to be a height of 3 from the x-axis. So it's tripling in height. Then we have this one that has a y value of 2. We're going to triple that y value and put it at 6. 2 times 3 is 6. Then we're going to quickly run off the graph here, but this had a y value of 4. We're going to triple that, and it's going to be up here at 12. Then when we're at -1, the y value was a half, and if we triple a half, we're at 3/2, which is 1 1/2, so it'll be right here. And if the next one was at 1/4, and if we triple that, we are at 3/4. So that's about 75% of the way up between 0 and 1. So what we end up having is something that looks like this. It's steeper than the other one, and so it has been stretched vertically, and it's still going to come down to getting closer and closer to 0 eventually. It didn't move the asymptote. The asymptote is still the x-axis, but that's roughly what a vertical stretch will look like on an exponential function. We've talked about on other kinds of transformations that it kind of always depends if the change that's being made is inside the function or outside the function. If it's inside the function, it's going to be some kind of horizontal movement or horizontal change, and it's going to affect the x value more than the y value, which is in a horizontal direction. If the change is happening outside the function, and this is what it would look like on an exponential function, to be outside the function, because the function itself is the parent function 2 to the x power. If it's outside the function, it is a vertical movement of some sort, or a vertical change, which affects the y value. So let's look at these two examples. This one is when the x plus 1 is all in the exponent, so the change is happening within the exponential function. It's a left-right shift when it's plus or minus, and the ones that are inside the function always do the reverse of what you think they should do, and so a plus 1 actually moves left 1. So what you can do is just point by point take each point and move it left 1 spot. So I'm going to take this point and move it left 1 spot, that point move it left 1 spot, that point move it left 1 spot, that point move it left 1 spot, this point move it left 1 spot, and this point move it left 1 spot. That is now the new transformed function with a left shift of 1. Now the green function is having a plus 1 outside the function, and that is an up-down shift, and these do not do the reverse of what you think. They do what you actually think they would, and plus is going up. If it was minus, it would go down. So this one, you would take the red points and you'd move them all up 1. So we're going to take one of the red points and move it up 1. Another red point, move it up 1. Another red point, move it up 1. Another red point, move it up 1. Then we're going to take the one that was at a half, and I'm going to move it up to 1 1/2. I'm going to take the one that was at a fourth and move it up 1 to 1 1/4. So it'll look something like this. And one thing I want you to notice is that if it's inside the function and it does a left-right shift, that's not going to change the asymptote in any way. The asymptote is still the x-axis. In other words, the function is getting closer and closer and closer to that asymptote, but never is going to touch or cross over it. The asymptote will move, though, when you have an up-down shift. So not only does every point move, but the asymptote itself moves up 1 as well. So each point moves up 1, but the asymptote also moves up 1, and so now the green graph is getting closer and closer to the green line, the new green line, and the asymptote of this line, of this function, would be y equals 1. So it turns out that that number will always represent the new asymptote as well as the shift of all the points. Once again, here is our parent function, y equals 2 to the x. By the way, the number doesn't always have to be 2, but in this particular case, I'm trying to keep them the same parent function all the way through my examples. And what has happened here is there's been a negative 1/3 multiplied in front. That is considered outside the function, so it will be a vertical change. And what the 1/3 represents and what the negative represents are two different transformations. The 1/3 is a vertical compression of 1/3, which means it's going to be smashed from top to bottom. And then a vertical flip is what the negative represents, and that it will be flipped over the x-axis or reflected over the x-axis. So let's do those two transformations one at a time. First, we're going to do the vertical compression of 1/3. That means every y value, however tall it was before, is going to get smashed down to 1/3 of that height. In other words, if the height or the y value was 1, then it's now going to be at 1/3 times 1, which is 1/3. So it's going to be smashed down a little bit. Then if the original point was 2 in the y value, then it's going to be 1/3 times 2, which is 2/3, and so it's going to be approximately right here. Then if the y value was 4 up, you can see the height was 4, then it's going to be 1/3 of that, which will be 4/3, which is about 1 1/3, and so it's going to be about here. Then the one that was at 8, if you take 1/3 of 8, you get 8/3, which is 2 2/3. And so 2 2/3 would be about right here, something like that. And then on the other side, it will be 1/3 of 1/3, and 1/3 of 1/2, I'm sorry, which is 1/6. So it's going to just get closer to the x-axis, and it's going to be hard to show the other ones getting smashed because they're already so close to the x-axis. But this is what it should look like, something like that. So it got vertically compressed. Then the whole blue function now gets flipped over the x-axis. It's a vertical flip, so it's a vertical motion. The y values are the things that are changing. So with a y value of 2/3, it's now going to go down to negative 2/3. The y value that was 1 1/3 is going to go to negative 1 1/3. So each of these points are flipping across the x-axis. What was 8/3 ends up being 8/3 in the other direction. And then the one that was 1/6 is really close to the x-axis on the other side. And the one that was 1/3 will be negative 1/3. And I believe I might have said, I don't know if I said 1/3 on this one, but it was 2/3. So our final transformed graph is this green curve which has a 1/3 compression and a negative, which represents a flip.